Okay, we've got quite a tricky one here. So I think the original for this is a 10-marker question off the top of my head. So what are we doing here? This is in effect question number 13. Yeah, 10 marks for this one. So what we want to do here is we need to use multiple techniques for calculus. We've got x, ln x of the curve here. We're told that this is the normal. And just to help here, this is point Q where they meet. And it meets at an exact value called e squared 2e squared. This is a normal, so it meets at a right angle. And it meets the x-axis at R. So we're told this point down here is R. And then there's a region which is bounded by C being the red curve, the straight line here, and the x-axis. So in other words, we're trying to find the area of all of this bit here. Okay, so that's a bit tricky. It's a bit tricky because, well, there's a lot of techniques you need to use. One of them is identifying that, first of all, we're going to do two different bits. Okay, so we've got an integration under the curve here. So that's kind of, let's call that area 1. And then we've also got a triangle. Let's call that area 2. So the triangle, you know, this isn't drawn, so we need to find out how to get those values. So there's going to be a bit of work in finding this bit out. We already know this bit, okay, because we know the coordinate. In fact, it might be helpful just to write e squared 2e squared here. And then the integration, how about the integration? Well, I suppose we need to find out a lower bound as well. It looks like that point's 1, but I'd need to actually show that that's 1. So we can get started in many, many different ways. But I think we should just let's just do the integration for part 1 first, okay? So the curve is x ln x. So I want to integrate it. Limits. What are my limits? Now, e squared is the upper bound. What's the lower bound? The lower bound is when x ln x is equal to 0, which can be, you can see that if you think of this as a product equal to 0, x could be equal to 0, and you see that one's there. So that one's x equals 0. How about this one here? This is when ln x is 0. If you apply e to both sides, you'll get that x is e to the 0, which is 1. Okay, so that's how you can find that limit there, which is not the easiest thing in the world, actually. So we're going between e squared and 1, and what are we trying to integrate? We're trying to integrate, let's get rid of that one. We're trying to integrate x ln x. Okay, so what methods do we want? Well, when you've got two very different functions sat next to each other and they don't seem to have some nice connection, like for example, I would say that this is nice because this bit can link to this bit. So when they don't have that, by parts might be the way forward. So I'm going to do by parts. I'm going to differentiate the natural log piece because that normally works quite well. And it also becomes 1 over x, which is related to that. So I think that's why it will work well. So I'm going to work these bits out, which means these bits will be 1 over x, and this will be v, which will be half x squared. And if I write them into my formula, so if I write uv minus integral of v du, I get the following. I get what? X ln x minus the integral v du. So that's a half, is it v du? V du, yeah. Half x squared times 1 over x. And this fixes itself quite nicely, this bit here, okay? I could pull the half out to the front. There's so many things I could do, but really what I need to spot is I need to spot that happens there, okay? That's the main thing. So this becomes x ln x minus a quarter, because x will become x squared and you get another half, so it'd be a quarter x squared. And it's a case of putting in the limits now, which are e squared and 1. Okay, so e squared and 1 for those ones there. That's how I can get my first area. So I think we just kind of go up here now and kind of tidy that up a little bit. So for my, let's do like this. So for my first one, I'm going to get e squared natural log e squared minus a quarter, and is that just e squared squared? It's e to the 4, isn't it? Okay, and the other one has a 1 in it, so I'll get 1. Natural log of 1 is a 0, so then I'll get a minus, don't forget the minus, and then this is a quarter, isn't it? A quarter. So just keep an eye on the show. That I'm not quite sure that our question generator can handle the complexity of this question, so I'm not 100% expecting it to be in that form. So natural log of e squared, because you can go like this and natural log of e cancel out, that's just 2. Okay, so this is going to become 2e squared minus a quarter e to the 4. And then there's a double negative plus a quarter. So I think that's what my area for number 1 is going to become. Okay, so we're doing integration by parts, and that's what I've got for that bit there. Now, how to do the other bit? So the triangle, I want to be using the fact that normal is given to me in the question. So I actually want to do some differentiation here. So we're going to just kind of go like that. And first of all, we're going to differentiate. So if y equals x natural log of x, the product rule says keep, differentiate, differentiate, keep, which gives me dy dx. So I said keep, differentiate x 1 over x. That's a 1. And then differentiate keep is natural log of x. So 1 plus natural log of x should give me the gradient in general of points along this curve. Now I want to know the gradient when x is e squared, because that would tell me the tangent, and then I can use that to get me the normal. So so I'm going to write, if I find the gradient at e squared, it's 1 plus natural log of e squared. That's 2, isn't it? We just talked about that. So it's 3. So the gradient of this tangent is 3, and that looks about right. That does look about 3 at that point. I want the normal though, so the gradient of the normal, is going to be minus a third. So now I'm starting to know some things about this line here. Okay. It's on a straight line. That's the gradient. I've also got a coordinate. So what we're going to do now is we're going to use y minus y1 equals mx minus x1 for the straight line. And we're going to, in fact, use this version. And you'll see why in just a second. So I'm going to write y2 minus y1 was 2e squared equals minus a third, this x that I don't know yet. What's this? Minus e squared. Now, I've written it in this format because the whole point of why I'm doing this is I want to find this, because when I find this, then I can find that distance there and find my triangle. So I'm not looking for like y equals mx plus c. I'm actually just trying to find a y value, an x value that goes with y equals 0. So now I've got this, I can sub that in here, and it's just going to save me a little bit of time. So 0 minus 2e squared equals, do we want to expand that out? No, I don't think we do. Minus a third, I'll just call it x. If we multiply everything by 3, or even minus 3, it makes everything a bit nicer. So 6e squared equals x minus e squared. So it looks as if that point is 7e squared. That's worked out surprisingly nice. 7e squared. 7 times, yeah, that looks about right. Okay, so what are we doing now? Well, let's work out the area of this triangle. So this triangle was 2e squared tall. It's 2e squared tall, wasn't it? And it goes from 7e squared to 1e squared, so that's 6e squared. So base times height, so 2e squared times 6e squared times a half. Don't forget the half. People love to forget the half. Is going to give me what? That's 6e to the 4, isn't it? So I think, and as predicted, yes, they were pretty close, but they didn't quite get it with this question here. So as predicted, it's sort of got e to the 4 in it. So we're just going to add these answers together, okay? So this was how you got area 2 in the end. So if I do 1 plus area 2, I think I'm just collecting the 6e to the 4s together, aren't I? So that's 24. Is that 23 over... I think it's 23 over 4, e to the 4. And then I'm just adding those other bits on. So 2e squared plus a quarter. Right, there we go. So I'm impressed we managed to fit all of that on the screen, as it is a 10-mark question. So it's an interesting one because you've got this mix of integration and differentiation as well. But I hope you found it a fun question to do.